Does it?
So for example number 2,
Spotted.
we're given the function f of x is equal to the square root of x. And they want us to find f prime of a, and they don't tell us what a is yet. Now if they tell us to find f prime of a, we still kind of do it the same way. By the way, it's 1/2 times 1 over x, or the square root of x, the answer.
Oh, yeah.
Okay. So the only thing that I'm going to do a little different here is that I'm going to say what is f of x minus f of a all over x minus a. And instead of h equals 0, we say as x approaches a. Now this is a little different, but f of x is the square root of x minus the square root of a all over x minus a. Now that would definitely give me the slope. The problem is the square roots. I don't like the square roots. So how can I get rid of square roots?
Rationalize.
Yeah, but they're not on the denominator. We only rationalize the denominator when they're on the denominator. Well, here's what I want to do. The reason I don't like the square roots is that I want to kind of get rid of the x's. I want to write a function in terms of a. If I plug in an a right now, the way that it stands, right, we're going to say x approaches a, right? So we can't forget that. That means at some point in time I'm going to plug in an a for x, and what happens in the denominator? I'll get a minus a, which is 0, and I don't want that. So if I hit the top and bottom with the conjugate,
Oh, yeah. Isn't that rationalizing?
well, did you say rationalizing the denominator?
No, I just did rationalizing.
Yeah, it is kind of rationalizing. But I don't want to say just rationalizing. What I want us to understand is what we're really doing. What we're really doing is we'll end up, this is a difference of squares, so I get x minus a on the top, then on the bottom I get x minus a times the quantity square root of x plus a, square root of a, like that.
Then you just get 1 over. Yeah.
Yeah, so then these will cancel, and I get 1 over the square root of x plus the square root of a. And remember, we're still taking the limit of all this stuff as x approaches a, and we're taking the limit as x approaches a. So what I'm going to do is wherever there's an x, I'm going to plug in a, right? So that equals 1 over the square root of a plus the square root of a, which is equal to 1 over 2 the square root of a. And that's what I said. It was 1/2 over the square root of x, but we've replaced the x with a. And so now whatever value I plug in for my a, because what we're really saying is that we're going to let x equal a. So this is just like the problem we did before, except it's done just a little different. That might cause some confusion in your homework too.